So you are welcome again in our organic class. So last lecture we talked about methods to prepare the amines compound. Okay, so we said there is three main methods to prepare the amines compound, this family. Number one is the nucleophilic substitution. Yes, and I already explained for you what meaning that. Secondly, reduction of other nitrogen containing functional group. Like what? Like nitro group, like SN, cyano group, tamam? Like amide. So today we start with the third method, the reductive amination of aldehyde and ketone. Okay, from the name, reductive amination. Okay, reductive, what meaning reductive? Reduction, yani. That meaning increase hydrogen atom. Okay, increase the hydrogen atom. So, and amination, that meaning we will make alkylation for the amine compounds to convert some compounds like aldehyde and ketone to what? To the amine. We said amination. Okay, amination. So from the name, it is clear for you now. Reduction amination, that meaning it is two-step reaction to convert aldehyde and ketone to what? To the amine. So reductive amination is two-step method. Look, two-step method that convert aldehyde and ketone into what? Into primary, secondary, and tertiary amine. Okay, that meaning this method to prepare the three types of the amines, the primary and secondary and tertiary. For this reason, this method is important method. Okay, not for example, Gabriel's synthesis, he just talked about preparation of primary amine, but here no. By this method, you can prepare the three classes of the amine: the primary, secondary, and tertiary. So he said we start to test this procedure with what? With ammonia, NH3. To prepare what? To prepare primary amine. There are two distinct parts in reductive amination. You have two parts, two reactions. Part number one, or the step number one, is what? Is the nucleophilic attack of NH3. Look, of NH3, because we test our procedure now with the ammonia, yes? With NH3 on what? On carbonyl group. Why carbonyl group? Because we talk about aldehyde and ketone. Okay, so the carbonyl compound, they are aldehyde and ketones. Okay, forms an imine, and you know what meaning imine. Last year you take it, imine or enamine, yes? The imine or the enamine, how the aldehyde ketone react with the amines compound to produce the imine or enamine, yes? So already you know these reactions, which is not isolated then. In this type of reaction, in this type of method, this imine, it will be not isolated, okay? It will be directly converted to what? To the amine, directly, inside the reaction, immediately, okay? So, step number two is what? Is the reduction of imine, okay? Of imine forms an amine. Amine, it will be entered to the reduction process to give you amines. So if you look to the ammonia here, the NH3, because we tested our reaction with the ammonia, NH3. So what is the difference between NH3 and this compound? The final amine. What is the difference? Okay, all the process is what? Yes? Reduction. Yes, reduction, but all the process, this step is reduction. But look to the amine, all the process is what? What is the difference between this nitrogen and this nitrogen? Okay, this nitrogen bonded to 3 hydrogen. That meaning we replaced 1 hydrogen by what? By alkyl group. That meaning this reaction is indirect alkylation. Indirect alkylation. Okay? Indirect alkylation. Replace 1 hydrogen by an alkyl group. So it is indirect alkylation, substitution reaction. Substitution reaction. So, do you understand what I mean? Okay, it is clear, yes? Reductive amination replace the carbon double bond oxygen. This is the carbon double bond oxygen by what? Carbon hydrogen and carbon nitrogen bond. Reductive amination. For this reason, we said reductive, look, hydrogen amination. Okay, reductive amination. That it will be give you good note to memorize this reaction. This two-step reaction, reductive and amination. So, the most effective reducing agent for this reaction here, we said it is reduction process. Any reagent we can use. The most useful reagent in this method is what? Sodium cyano-borohydride. Okay, it is sodium cyano-borohydride. This reagent, it is very useful in this step. Okay, it is one derivative of what? Of sodium borohydride. Sodium borohydride NaBH4. Okay, so we replace one hydrogen by Cn. We say sodium cyano-borohydrate reagent. It is very useful reagent in this process. Okay. So, do you have a question here? Do you have a question? Do you understand what meaning the process now? So, if I ask you, give me one example about indirect alkylation for the amines. Indirect alkylation for the amines. You can say to me it is the reductive amination and give me one example. Write for me any example you wanted. Okay? The question is what? Give me one procedure or one method can be present to the indirect alkylation of the amine. Indirect alkylation of the amine. Okay? Indirect alkylation, substitution reaction of the amine. Can give me any, we said, is the reductive amination of aldehyde and ketone, and give me one equation about this method. Do you have a question? So, reductive amination combines two reactions we have already learned in different way. Yes, you know what meaning amine, how the amine will be prepared, the mechanism for preparation of the amine. Yes? So, two examples are shown here. We have two examples. The second reaction, noteworthy because the product, this is the product. Okay, look, this is just one reaction. The first reaction, look what we have here, acetone, yes? This is the acetone. With the NH3, just we replace the carbonyl by NH2 and carbon hydrogen. Okay? By NH2 and carbon dihydrogen. By this reagent, look, it is two reductive amination. It is two processes in one reaction. Okay, two processes in one reaction. Firstly, the ammonia it will be react with the ketone, and the amine it will be formed directly. When the amine formed, directly go to the reduction with this reagent and give you the final product. Do you understand? So, look to the second one. Second one, he said this compound, look, is simple compound, very simple. This ketone, what is the name of this? Do you know? This is the acetone. Yes? This is the acetone. Okay, phenyl acetone. Okay, phenyl acetone. So, this compound is simple compound. It will be react with the NH3 reductive amination to prepare this product. This product actually it is a drug compound. Is what is the potent central nervous system. Okay, stimulant. يعني منشط للجهاز العصبي. Okay, منشط للجهاز العصبي. So it is very important drug here. It will be prepared by just one step, the reductive amination in this subject. So, do you understand? Okay. So what happened here? Just we replace the carbonyl. This is the carbonyl. Okay. To the what? To the carbon hydrogen of a carbon hydrogen. And carbon nitrogen, this is the carbon nitrogen. So if you have here hydrogen, it will be remain hydrogen. If you have here alkyl group, it will be N alkyl group, like that. Okay. So I will give you another examples. So with the primary, this is about ammonia. Just we tested about with ammonia now. Okay. I will replace the ammonia by primary amine by secondary. So with the primary and secondary amine, okay, look the difference here. It is not ammonia. It is a primary secondary amine. Okay. As a starting material, look, starting material, it will be react with the aldehyde or ketone, this aldehyde or ketone, to enter to the reductive amination. Okay, reductive amination is used to prepare secondary and tertiary amine respectively. And that meaning if you use the primary amine, give you what? Secondary amine. Why? Because I told you before that the reaction is what? Is alkylation for the amine. So if you make alkylation for this amine, other primary amine, alkylation meaning to replace another hydrogen atom with alkyl group. So remove hydrogen, put alkyl group, it will be secondary amine. If you use secondary amine like that and go to the reductive amination, that meaning we replace this hydrogen by alkyl group. It will be give you tertiary amine and like that. Okay? So if again, he said with the primary and secondary amine as starting material, reductive amination is used to prepare secondary and tertiary amines. Not the result. Reductive amination uses aldehyde or ketone to replace one hydrogen atom on the nitrogen, as I told you, on the nitrogen. Okay, by what? By alkyl group, making what? Making more substituted amine. That meaning substitution, alkylation for the amine. You can write here not substitute amine, that meaning alkylation of amine. هكا جي بي سي ار هاتيه نظانا. Okay. Alkylation of amine. So 1, 2, this aldehyde or ketone with the primary amine give you amination, imine, this is the amine. You know the amine, yes? Okay, that meaning here in this step what we have minus H2O, if you remember. Minus H2O. Okay? Minus H2O to give you amine. And amine directly by reductive with this reagent we said sodium cyano-borohydrate. Tamam? Remember that sodium cyano-borohydrate. Okay? It will be give you secondary amine. And if you use secondary amine like that, if it give you iminium ion, okay, iminium ion. Why iminium ion here? Why iminium ion? Look, here we have imine. Here we have iminium ion. Why? Yes, this nitrogen has 2 hydrogen atoms. 2 hydrogen with 1 oxygen, it will be minus H2O. But here, we don't have 2 hydrogen and 1, but just we have 1 hydrogen, 1 oxygen atom. For this reason, it will be give you iminium ion. Okay, iminium ion, not imine, iminium ion, because our amine is the secondary. Okay? Okay, anyone if you want, no problem. No, you have to two-step reaction. Okay, two-step reaction, give you imine and inamine. Okay, like example if you want, if you ask me, okay, just give me like this reaction as example.
Yeah,
Okay, but if you that this is not mechanism. No, كمعادلة, this is all the steps, 2 steps. That meaning you want to explain the 2-step reaction, you have to write like that, imine and if you go to explanation, okay. But if without explaining, just give me one example. This enough. Okay, with not imine, this enough. Okay. Now it is clear for you. Do you have a question? No question? So, example here, draw the product of each reaction. Okay, what is the product of this now? What is the product of this? This is the cycle. This is the cycle. This is the cycle. Here, what we have? Carbon, okay, hydrogen, another hydrogen atom because it is reductive, yes, and nitrogen. This nitrogen, what has here? Has 1 hydrogen and 1 methyl group. Okay, this is the product. This is the product. This is the product. Okay. With this number C. Okay, cyclohexanone, it will be react with the amine. Reductive amination. What is the product? Directly, this is the cyclohexanone. Okay, cyclohexanone. Okay, what we have to do? The reactant is what? Is NH ethyl biethyl. Okay, biethyl. Okay, biethyl. That meaning diethyl amine. This is the name. Diethyl amine. Yes. And this, what is the product directly? we will cancel the carbonyl group because we said it is the carbonyl group. It will be converted to one carbon and one hydrogen, and the other is what? Nitrogen. This is the product. Okay, this is the product. This homework for you, but I give you the idea. So the same thing here. This our compound here. You take it before that, and also like that. Okay, now he said in reductive amination, with one of the hydrogen atom bonded to the nitrogen replaced by alkali group. For this reason, what I say to you is alkylation. Yes, it is alkylation. As a result, primary amine is converted to the secondary amine, and secondary amine converted to the tertiary amine. Okay? In this reaction, this CH3 NH2 by 2, it is the primary amine. This is the primary amine. Convert to what? To the secondary amine. Convert to the secondary amine. Okay. Is it clear for you? Tertiary don't give you amine aslan. Okay? Tertiary amine. If you use here tertiary amine, tertiary cannot be able to give you the imine or iminium ion. Okay? So it will be not used to this reaction. It will be not used to this reaction. Why? Why? Because we want to convert the primary amine to the secondary to tertiary. But أصلاً أو tertiary, it will be going to what? For what? Okay, there is no further alkylation for tertiary. It will just give you a quaternary ammonium salt. Okay, give you quaternary ammonium salt. Okay. What we have in the next slide here. To use reductive amination in synthesis, you must be able to determine what aldehyde or ketone and nitrogen compound are needed to prepare a given amine. So if somebody told you, I want to prepare this amine, by reductive amination. This is another type of questions, talaba. Okay, I want to prepare this amine by reductive amination. What you have to do? You have to think about what starting material used, stable or suitable to give you this compound. Okay, so this is the idea. Do you understand? If I told you prepare for me this amine, okay, what is starting material? Any ketone and any amine will be react by reductive amination, give you this. This is the idea. Okay, so to use reductive amination in synthesis, you must be able to determine what aldehyde or ketone or nitrogen compound are needed to prepare a given amine. So you must work backwards. Yani think about the starting material. Okay, we said backwards in the retrosynthetic direction. Retrosynthesis is back steps reaction. That meaning, if I told you, for example, prepare for me this compound, you will be go to the backward to the starting material, not to the another compound. Okay, but any starting material is useful. Like that, we said by this arrow. Okay, any starting material by reductive amination. That meaning any ketone and any amine can be react with each other by reductive amination to give you the product. This is the retrosynthesis, okay? Backwards reaction. So, keep in mind the following step. You have two important points here. Number one alkyl group on the nitrogen atom become from the carbonyl group. That meaning one alkali group, either this or this or this, it will become from the carbonyl group. You have to think like that. Okay, you have to think like that. Okay, what you said? Okay, let me finish. So, secondly, the remainder of the molecules come from the NH3 or the amines derivative. So if you say this, it will become from the ketone. That meaning the remain part, it will be coming from the amine. Okay, for example, this, it will be from ketone or aldehyde. Any ketone or aldehyde, any ketone or aldehyde, directly this part. There is no another probability, just like that. Because this, it will become from the ketone. Okay, if I say to you, this, the remain, it will become from the amine. Any amine, this the amine. Put hydrogen, this is the amine. Yes, you can make this ketone or aldehyde, not just ketone. So if you say this comes from aldehyde or ketone, any aldehyde or ketone, this give you this it will be aldehyde. Why? Because we have here, what we have here, we have two hydrogen here. That meaning directly it will be coming from this part, CH3. Okay, the remain, it will be from the amine. Any amine, nitrogen have a nitrogen, hydrogen have a hydrogen, Gh, this alkyl group. Any amine, this is the amine. So this the amine. So this react with this by reductive amination, give you this. This react with this by reductive amination, give you this. Yeah, it is right. It is right. It is possible. No different. But here you use aldehyde and what? Secondary amine. Here you use ketone and secondary amine. One of them you used ketone and one of them you used aldehyde. Do you understand the idea? Okay, this is the idea. So, for example, I give you example here, but we have another example here. For example, 2-phenylethylamine, this 2-phenylethylamine, this is the compound. So it has only one alkyl group bonded to the nitrogen. Just one alkyl group bonded to the nitrogen, ever. Just one alkyl group bonded to the nitrogen. So this alkyl must be coming from what? Carbonyl compound. Look, this example is a primary. A primary, not like this example. This what? Here, tertiary or secondary. Tertiary or secondary, can you suggest two methods to prepare this compound? But if you have a primary, no way. Just this is coming from ketone and this coming from the ammonia. There is no another possibility to prepare this compound. Yeah? So this comes from the ketone or aldehyde and this comes from the amine. How many hydrogen we have here? 2 hydrogen. If you have 2 hydrogen, not 1, 2 hydrogen, that meaning 100 by 100 will come from the aldehyde. Just make this carbonyl, it will be aldehyde. Cannot be from the ketone. Cannot be from the ketone. So this part, it will be coming from the aldehyde or ketone. This is the aldehyde. Okay. Or this part, the NH2, 100 by 100 from the ammonia. And this, it will be interlock. So this is the ammonia. And this compound, this is the carbonyl compound, react with each other by reductive amination to give you what? To give you this, a product. To give you this compound. Okay? Do you take the idea? This is clear for you? Do you have a question? Just make it two part. This part comes from aldehyde and ketone, and for the NH2, 100 by ammonia. Maybe we have another example. Next slide. Let us see what we have in next slide. The next slide, it is near from our example here. Look, what aldehyde or ketone and nitrogen compound are needed to synthesize this compound, N-ethyl, this N-ethyl cyclohexanamine. This cyclohexanamine, we have on the nitrogen substituted, we have N-ethyl. Okay, by what? By reductive amination. So think don't look to here. Think here. You will be saying this, it will be coming from aldehyde or ketone, or from the amine. Yes, any aldehyde or ketone. Any aldehyde or ketone. What is the name of this? Methan, ethan, aldehyde, al, ethanal. Okay, ethanal. This is the ethanal. Okay, so this part comes from the amine. Okay, any amine, just put here hydrogen. It will be what? It will be this cyclohexanamine. Yes, this the first method, the first probability where. Okay, if you say this comes from ketone or aldehyde, that meaning this 100 by 100 come from the hexanon. This is the hexanon. And this comes from the what? From the amine. Any amine, just put the hydrogen here. It will be this, the amine. What is the name of this? Ethanamine. Okay? Yes. Do you understand? Do you have a question? Is it clear for you? Yeah? Clear for you? Okay. No problem. That meaning we have two possibility method to prepare this compound. Firstly, here he show you, yes, if you have more than one possibility, maybe I will write in my question, write all possibility to prepare this compound by reductive amination, okay? If you have 1, 2, 3. So here, what do you think if I write for you this example? Look. So this is my example, okay? Prepare for me this compound, or write or possible method to prepare this compound by reductive amination. This. That meaning, yes, we have three possible methods. Number one, this comes from aldehyde and ketone. So this it will be amine. Method number two, this comes from aldehyde ketone. This or this from the amine. Possible method number three, this comes from aldehyde or ketone, and this it will be from the amine. This homework for you. Yeah. This the iso here? Here? Okay. The propyl is, she said, convert this to the isopropyl. That meaning this it will be from ketone, not aldehyde. Yes, this is your question, I know. So write this as homework for you, and you can change it in your horn. Write another molecules. You write another molecules, okay? Another molecules and test it with by reductive amination. How possible methods to prepare this compound? You put it, you write it, you draw it, okay? Okay. Here another example. What starting materials are needed to prepare each drug? Look, each drug, avadrakin, okay? They are drugs. By using reductive amination. By using what? Reductive, give all, look to the question. Give all possible pairs, yani all possible methods. Okay, all possible methods of compound when more than one route is possible. More than one methods they are possible to prepare this compound, draw it. Okay, so I told you before that if you have NH2, that meaning you have just one method. This comes from the amine, this comes from the aldehyde or ketone, khalas. But if you have like that, not NH2, yes, this it will be come from two possible methods, and you have. Yeah, you have to resolve this homework. Okay? I don't resolve it now. Explain why phentermine, this is the compound, cannot be made by reductive amination reaction. He said this cannot be prepared by reductive amination reaction. What is the structure of this? Look, we have phenyl. What we have? We have phenyl. This is the phenyl, and directly bonded to what? CH2, and the CH2 to what? To the carbon. This carbon to do CH3, and NH2. So, explain why this compound cannot be prepared by reductive amination. If you said this, it will be coming from the amine. Yani this coming from what? From the NH3, no problem. This coming from the NH3, no problem. But this is, if you say it will be coming from the ketone, it will be like that. Like that. CH2, CH3, and double bond oxygen. Are this right? No, it is not right. It is not right. Now, because The carbon bonded directly to the NH2 group, they don't has hydrogen, they are alkylated. This carbon alkylated by methyl group, substituted by methyl group. There is no hydrogen. There is no hydrogen to give you imine and then or iminium ion to go to the reductive to give you the amines. Okay, there is no hydrogen here. There is no hydrogen. That meaning any compound, the carbon that directly bonded to the NH2, there is no hydrogen atom, cannot be prepared by reductive amination. Cannot be prepared by reductive amination. Okay, and write the name for this compound. Here, another homework. Draw the product of each reaction. This is easy. If you say draw the product, directly give me the final product. Look, final product, final product, final product, final product. Replace the carbonene with what? With NHCH3 and like that, like that, like that. Okay? The idea is easy, and also the principle for this method also useful and easy. It's not complex. Okay? It is not complex. If we change, she asked if we change this methyl group by hydrogen, can be prepared by reductive amination? Yes. Yes, can be prepared. This comes from the ketone, it will be ketone, and this comes from the amine. Okay, this comes from the amine. Do you understand? So what we have next slide? Resolved homework. Here we have resolved homework. He said, what starting materials are needed to prepare each compound using reductive amination? Give all possible. The same thing. Give all possible pairs, as give all possible rules, give all possible method to prepare this compound. Okay, this compound, how many routes they have to prepare it? Look, NH2, just one method. Khalas, there is no another possible method to prepare this compound. This comes from the ammonia. This okay. Now this is tertiary amine. Tertiary amine. Look, this is alkyl group like alkyl group. That meaning this one method. Here we have methyl. It will be just, yes, it will be two methods to prepare this. Yes, it is tertiary amine, that meaning it will be a three method, but we have identical alkyl group. Okay, it will be the same methods. Okay, look to this. This CH3 methyl and this isopropyl, that meaning how many methods we have here? Two, yeah, two methods. Okay, two methods, and here write it down, two methods, this. Okay. This compound, we have methyl and we have all this alkyl. That meaning how many routes to prepare this compound here? Yes, we have two routes. Okay? You understand? So, do you have a question? Is it clear for you? Okay? Is it clear for you? No question? No notes? So, today I will finish to here. Okay? Inshallah, we'll continue to the next lecture. And if you don't have a question, you can take your time. See you. Bye.